Hello everyone, my name is Patty and I'll be introducing you to our lovely Capstone team. Here we have Ayse, Stephanie, Tiffany, and myself. With the spread of COVID-19, people are having to self-isolate and stay home. We want to provide people who are social distancing with the opportunity to virtually meet and have fun. Therefore, we decided to create a multiplayer 2D game inspired by Pummel Party and Super Mario Party. Let's imagine Sarah at home by herself. She has nothing else to do, so she creates a game room and asks three other fellows to join her. To advance on the board, she rolls the dice. If she lands on a coin, the coin triggers one of our mini games. And to win the game, whoever reaches the end of the board first win. I will pass it on to Ayse to talk more on the technology behind the game.
Thank you, Patty. For our project, we used Phaser on the front end, Express on the back end, and Socket.io for real-time event handling. We utilized Phaser's built-in scene manager to seamlessly transition between our board game and minigames, while ensuring that shared game states such as queue or player score is passed between scenes. We employed Phaser's arcade physics engine to move and animate our sprites. In order to create an isometric board, we ventured outside of our main game engine and utilized some external tools. We built a set of modular tiles using Blender, combined these tiles into a single image called a tile set using Texture Packer, and used tiled to generate a map that references our tile set and stores the position of each tile within the final image. Now Tiffany will walk us through the challenges we faced when implementing multiplayer functionality using sockets.
Thank you, Ayse. As she mentioned, we utilized Phaser 3's built-in capability to pass data between game scenes. For simple scenarios such as rendering a start game button for only the room creator, we can pass a data object containing room creator information. As our game design grew more complex, however, we realized there was a race condition developing where some clients pass information faster than others, and this caused the player order on the board to be out of sync. For multiplayer games, timing and order is essential to making sure all players see the same thing on their screen. So to combat this issue, we decided to let the server handle player data. We implemented WebSockets to emit client information to the server on key events, and then had the server broadcast it back to all clients so everyone has the correct information. Now Stephanie will talk about future features.
Thank you, Tiffany. So I'm going to close this out by saying we want more. We are ambitious. Our game structure leaves us open in the future to easily add features like more mini-games, not just 4-player or solo, but 2 versus 2, 1 versus 3, or even teamwork games, which all 4 players have to work together. And as we complete these games, they can be integrated quickly and seamlessly. We're also looking at additional multiplayer socket features like messaging or voice chat system so that you can communicate with the players in your room. So that's Super Quarantine Party. Thank you, everyone. We'd like to thank our team, our instructors, Sarah and David and Ben. We'd like to thank Megan and all of the fellows and, of course, all of our classmates at Grace Hopper. We've had a really great time together. So thank you. Come play with us.